All right, hello guys. So this video is going to take you through molecular structure, uh, lesson number 5. So the unit is molecular structure. This is lesson number 5, balancing chemical equations. We already did cover balancing chemical equations. This one just has what I would consider to be a little bit more complicated problems in it. So basically, remember when you are balancing a chemical equation, you want to list the elements that are present and determine the number you have of each element on both sides of the equation, the reactants and the products. And then you just start putting in coefficients to balance it. If you need to double something, if you need to triple something, you just try to get your numbers to line up on both sides. So you start with metals, then you do your nonmetals, keep your polyatomic ions together if you can, and then do the elements of oxygen and hydrogen. Save those for last because those are usually by themselves. So the one that's by itself, usually do that last. So here's the first example that is worked through in the lesson. So I'm just going to do this one with you. So if I look on the reactant side, I have one sulfur. I have 1, 2, 3, 4, 5 oxygen. So I can already see that's going to be a problem. And I have 2 hydrogens. Then on this side, I have 2 hydrogens. I have 1 sulfur and I have 4 oxygens. So there's a few kind of red flags sticking out at me here. Like already my hydrogens and my sulfurs are balanced, but I have 5 oxygens on one side and 4 on the other side. And I know that that's not going to work. There's no way that I can do that. So basically the thing is now you just have to kind of pick something and double it and see what happens. Generally, I say pick the odd one. So pick the side that has the odd number on it and double it. But in this case, it wouldn't work very well because those 5 oxygens are actually spread out among multiple things. So what I'm going to do is pick the oxygen in here that is the odd number, the one that has an odd number in it, and I'm going to double that. So I'm going to pick this water right here and put a 2 in front of it. I know this is, I'm looking at balancing my oxygens and hydrogens last, but I'm going to mess that up a little bit. So if I put a 2 in front of this, that now gives me 4 hydrogens, but that gives me 1, 2, 3, 4, 5, 6 oxygens. That's at least an even number. I can work with that a little bit better. I'm still not even though. So now that I've got my hydrogens kind of messed up here, I need to fix that on this side. So to fix it, I have to put a 2 in front of this, which now gives me 4 hydrogens, but that also gives me 2 sulfurs, and that now gives me 8 oxygens. So now I've got my hydrogens balanced, but I messed up my sulfurs. I'm saving oxygen for last. I'll worry about that in a little bit. So how am I going to get 2 sulfurs? I have to put a 2 in front of the sulfur dioxide right here. So when I distribute that 2 to everything, I now have 2 sulfurs. And now if I add it up, I have 4 oxygens plus 2 oxygens plus 2 oxygens. So now I have 8 oxygens and I end up balanced. So I'm going to work out one more reaction from the lesson with you. I'm going to work out this one right here. So this is an example from your notes. So it is calcium nitrate plus sodium hydroxide gives you sodium nitrate. This is a double replacement reaction where they're switching places with each other. You're going to learn about those next week. And then calcium hydroxide. So the first thing that I have to do here is write down all of the elements that I have. But I don't know if you guys remember from the last lesson on balancing equations, we want to keep polyatomic ions together if we can. So because this polyatomic ion of nitrate is together here and it's together on this side of the equation, I can keep it as kind of one entity instead of thinking of it as separate nitrogens and separate oxygens. So I have calcium and I have nitrate. And I can do the same thing with the hydroxide because the hydroxide is present on both sides of the equation. So I have sodium and I have hydroxide. So if I do my numbers, I have 1 calcium, I have 2 nitrates, I have 1 sodium, and I have 1 of this hydroxide group. Now on the other side of the equation, let me move this over a little bit. On the other side of my equation, I have 1 sodium, 1 nitrate, 1 calcium, and 2 hydroxides. So it really doesn't matter what we solve or what we balance first, because our metals are already balanced. So now if we just move on to our polyatomic ions, it really doesn't matter which one we do. I have 2 nitrates on this side and only 1 nitrate on this side. So I'm going to have to put a 2 in front of this. So now when I distribute that 2 to everything, that means I have 2 sodiums and I have 2 nitrates. Well, the only way, now that I have 2 sodiums on this side, the only way to get 2 sodiums on this side is to put a 2 in front of this. And now I have 2 sodiums, but I also have 2 hydroxides. And that's what I needed on the other side. So I ended up balancing my equation. So there would be a coefficient of a 1 in front of this, a 2, and a 1. So that should help you work through this lesson. And if you need any additional help, please let me know.